My w niedługim czasie uruchomimy platformę prac dyplomowych. To jest do wszystkich Państwa, nie tylko dyplomowych, platformę tematów, projektów. Pewnie większość z Państwa będzie planowało pójść jeszcze na studia magisterskie, albo już Państwo są na studiach magisterskich. I dzisiaj mieliśmy spotkanie z dziekanami i z firmami, gdzie firmy będą mogły wprowadzać tematy do realizacji na uczelniach, więc myślę, że coś takiego byłoby dla Państwa też ciekawe. Proszę nas śledzić, może też polubić na LinkedInie, właśnie dodałem link. Także zachęcam też do dłuższego obserwowania, bo będzie się pojawiało więcej produktów. Dziękuję Pani Julii. I teraz następna prezentacja będzie panów Michała Laskowskiego, pana Macieja Rogali i pana Filipa Żarneckiego, także zapraszam.
Dzień dobry.
Dzień dobry, ładnie słychać i widać.
No, super.
Czekamy na prezentację.
Tak, udostępniam ekran.
Tak, ładnie też ekran widać.
Super. Okay, so I'll present in English, and I shall start because there's not much time. Our work is on the topic of deep learning-based sentiment analysis. My name is Filip Żarnecki. Good evening. I have carried out it along with Michał Laskowski, Maciej Rogala, and the huge help of Agnieszka Mikołajczyk, because it wouldn't have been possible without the help of Voice Lab and Digital Innovation Hub. And our work consultant, who is a machine learning researcher and PhD candidate over at Voice Lab, Agnieszka Mikołajczyk. And we have carried out our thesis on Politechnika Gdańska, majoring in data engineering, and our supervisor was Professor Maciej Niedźwiecki. I will briefly talk about motivation behind the work, about training data needed for the solution, for the model analysis that we have carried out using the model, and also about XAI, which is explainable artificial intelligence, which was an addition to our thesis at the end. So basically we wanted to do something practical that we could use later on in some interesting use case, which happened to be an analysis of Twitter data, showing us how COVID-related subjects are reflected on social media. So that's the story behind, and going on to the solution, we needed some training data. So what we used was a set called Clarin.si from the platform. It was around 100,000 examples labeled to three classes, negative, neutral, and positive, and that allowed us to train our model. As you can see, the data was not very pretty. If you know Polish, then you can analyze the sentences. The first one, okay, there happened to be good examples as well. It can definitely be positive, but then in the second one, there is some noise, some random letters appearing. So the data was noisy. And also in the third one, we can see that sometimes the labels were given at random, I guess, because it's hard to take from a sentence rób hałas jak dzieci od pierwszej D, to może się zlitują. Well, it's hard to define what label is that. Also, there's some noise, so it wasn't easy. Partial fix for that was data preprocessing. We needed to delete duplicates because there were some. We needed to delete ambiguity. If one tweet was labeled two-way, we need to delete some mentions and some reserved to Twitter words. And also we replaced emoticons with their meaning in the language. So just a smiley face, for example, ended up being happy, the word happy. So we can see it's an extreme example of the preparation. We have duplicate, ambiguity, some links, some numbers, some tags, etc. And what we ended up with was just the sentence at the bottom with everything cleaned up nicely and ready for the training process. Was there any COVID-19 data? Initially, no, but we have labeled about 100 examples additionally by hand, which was on the topic. And we also needed to extend the vocabulary of our model because it's the nature of our solution that there is a finite vocabulary. We extended it with additional tokens just to let the model know about existence of such. Then the model itself is based on a bird, Polish bird, which is called Herbert. First, we have a tokenizer to tokenize the input data, then the Herbert, which produces embeddings, then BGRU with dropout, and finally a fully connected layer with activation. If you don't know what is Herbert, it's basically a huge language model based on transformers and the idea of attention. I recommend reading into it because it's state of the art in NLP problems. It's pre-trained on huge text corpora, more than 8 million documents from such sources as NKJP, Wikipedia, wolne lektury, etc. And it just gains a huge amount of knowledge, of language knowledge, and then can transform our input data into embeddings, so basically into numbers. So, for example, a sentence, I like my snowboard, first gets divided into tokens, and then the vectors of 768 length are produced. And going to the performance on Twitter data, it was around 72%. And the metrics, this is despite the annotation discrepancy, the difficult language, common sarcasm occurring in the dataset. So we say that it's a really good score, and we can also compare it to performance on a bit more clear data, which are conversational examples from banking domain, which we obtained from our cooperation with VoiceLab, and we fine-tuned the model couple hundred data examples, and we validated with cross-validation. So these are reliable, quite reliable results, and it's around 86-87%. So it's quite decent. Then we're going to the analysis on Twitter, where we just basically we scraped the Twitter and took data from beginning of March 2020 to August 2021 on the topic of COVID with such keywords like szczepionki, pandemia. We manually extracted keywords from Twitter that were trending to get accurate data, and we obtained 2 million tweets. We got the content and some metadata like number of likes, number of replies, comments, etc. What we were able to get. And you can see the distribution where the negative ones really overwhelm the rest. So we can already see some indication of the sentiment on the platform regarding the COVID. And the analysis itself, we used the predicted sentiment and also some additional metadata like time of posting, number of likes, retweets, and comments. And first, we obtained an interesting correlation with some events happening in the world. There are some spikes. The red line is number of negative tweets in the time series, and there are some spikes. The first one is postponement of presidential election. The fourth one is the return of hard lockdown restrictions. The fifth one, number 5, is the beginning of vaccination, and number 7 is daily record of infections. So as you can see, there are some negative spikes correlating with events, which is interesting that it's reflected so much and to such extent on social media. We also identified some negative trends. Here, the bigger the tag is, the more popular it was regarding the count. And we can see some negative trends like pandemia, nie szczepimy się. So people like to catch up those phrases and retweet or use in their own tweets, and it went trending. We also took a closer look at users, but we don't have much time to get in detail. But we identified people that were most often mentioned in negative tweets. These were politicians, some media figures, public figures. We also identified negative influencers who posted a lot of content that had a lot of reactions. For example, there were accounts with over 1,700 negative publications and not much other like positive or negative. And also we identified spam accounts that were sometimes tweeting as much as 24 tweets per day during their time of posting, which could indicate, for example, some bot accounts. So there was a lot of activity on social media. Okay, and coming to the end, closer to the end, the XI, Explainable Artificial Intelligence. We also wanted to add this one more thing to our thesis to better understand our model's predictions, because XI is basically to see the why of model decision. And so some words in our sentence could indicate one sentiment more than others. And in this case, for example, love and pizza could indicate positive sentiment. Then animal could indicate neutral sentiment, and hurt and badly could indicate negative sentiment. And that's what we want to figure out. We used two methods, LIME and SHAP, which are quite similar. These are complicated, at first look, complicated visualizations, which we won't focus on, but they basically perturb our input. So they hide certain words and check how the prediction changes. And here we see how each word contributed to each sentiment. So for example, word zestresowana was very negative. And this enabled us to see how each of the words contributed to each sentiment, and to better see what the model, how the model sees the input that we provided. So here we have the visualization, our own, with the help of LIME. It changes the order of the words, that's why it looks like this. But the SHAP one looks a bit better. And this way, thanks to the SHAP or the LIME, we can see which words contributed to each sentiment. And it's model agnostic, so we don't need to get into the architecture of the model inside of it, but we just take the input, take the output, and it does the work thanks to this. And that would be it. Thank you very much for your attention, and have a pleasant evening.
Thank you very much. Bardzo dziękuję. Super praca, bardzo ciekawie się tego słuchało.